This video is kind of a simple unofficial proof to show you why does the formula mu equals the expected value of x, which is the sum of each x value, times the PMF, why does that actually give you the average that we're used to doing? So let's first find the average the old-fashioned way. So let's say I have a list of numbers, and my numbers are 2, 2, 2, 4, 4, 4, 4, 4, 4, 7. So this is my list of numbers. Let's find the average. So this is pretend you're back in a much previous math class. You haven't learned anything about expected value. You're just finding the average. And we would do it. We would add all of those up and divide by how many there are. So there were 7. And this gives me 3.7. Now you'll notice that when I wrote this, I was too lazy to try and write 6 fours again. I didn't really want to write it again. So what if we tried to make this just a bit simpler? Okay, or kind of a little bit. Instead of writing 2 plus 2 plus 2, I could write 3 times 2. Okay. And then there were 6 fours, so I could write 6 times 4. Plus there's 1 7, so 1 times 7 divided by 10. So basically we're kind of rearranging for a proof here. Now this will still give me 3.7. Now if I wanted to, I could change this one more time, and doing all of my mathematical tricks, I could say this is the same as 2 times 3 over 10 plus 6 times 4 over 10 plus, sorry, no, wrong one. I wanted to say 4 times 6 over 10 plus 7 times 1 over 10. Now this works because I'm just dividing each value by 10, and I just switch the orders of the 2's and 3's. The order you're multiplying doesn't matter. So this will still give me 3.7. Now the reason I wrote it like that is because what if we found the PMF? For this, I'm going to write down each x value and each probability. So I have the x values 2, 4, and 7. There are 3 2's out of 10, so if I want to write a probability for that, it would be 3 out of 10. There were 6 4's, so it would be 6 out of 10. And 1 7, so 1 out of 10. So now if I was to find the mean, or expected value of x, using the sum of each x times the probability, what would that look like? I take my x of 2, times it by 3/10. And then I take my next x of 4, times by 6/10, and my last one of 7, is my x value times 1 out of 10. And this still gives me 3.7. So you can see that we started with our old definition for the average, and we rearranged it until we get the same thing as our formula for the expected value. So that's kind of what they realized. They said, well, how would we do this with our old definition for finding the average? How can we make that work for the PMF? And that's how it works. And that's what you do for discrete. And then if it's continuous, then we don't have a PMF anymore, but we just say, okay, instead of having like 3 or even 100 different possible x values, now we have infinitely possible many x values. And instead of sums, we move to integrals. So then it becomes the mean, or expected value of x. So instead of a sum, we do an integral of each x value. And instead of a PMF, so we won't have an xi anymore because there's infinitely many, we'll just do x times the PDF of f of x dx. And we go from negative infinity to infinity. That's just our way of saying add up all of the possible x values times the PDF, which is kind of like the PMF, but not really the same because we've now switched to like infinitely possible x's, and it does some interesting things. But that's why the formulas work.